Okay guys, I think I fixed the quality on my recordings, so hopefully this will be better. But I'm gonna show you how to do it on Ansys, kind of the steps I took, or the approach I took. So of course, start off by getting all this filled out, apply the material, general materials. You want to choose structural. Of course, you should already have structural steel on yours. But what you want to do is go to your Young's modulus, which is line 8. Apply that to be 1, because that is what is needed. Let's see. And then here we're going to go into geometry. Now, before you go into geometry, make sure it's highlighted. And right here, you're going to have this properties of schematics. If you don't have that, go to, I think it's views, and you should just be able to click it right there. But what you want to do is change that 3D into a 2D analysis. There we go. There's the word. So, and then click on New Design Modeler. I find that this works better than your new space claim geometry. And just let's let it load up. Okay, here we go. So, what I would like to do is pick the XY plane, and I'll click on the Z axis, make it normal to what I'm looking at. So here we're going to do a sketch. It's a common rectangle. So here, and then click on dimensions, general. You're going to click on your horizontal and your vertical. So now your horizontal, from the homework, it should be 5 meters. Now, they don't tell you what the vertical is, but we can safely assume that it's 1, because the equation for inertia is base times height squared over 12. So that'll come into play in a minute. So once you got your sketch done, go back to modeling, and you're going to want to do your sketch. So here, what you want to do is go to Concept, Surface from Sketches, and click that, and your sketch should already be applied. Here you want to pick 12 meters to cancel out that division by 12 for your inertia problem. And you're going to apply that to that sketch. Generate, and you should generate just a 2D plane right there. But when you go into ANSYS, it will thicken to 12, but only analyze this 2D object. So let's exit out of here. Go into Model, Edit. Okay, so here is our 2D object for analyzing. Again, go to the Z-axis. So here you need to assign it the material for, so E can be 1, structural analysis, we changed that. So right before you do anything else, what you want are, so you want remote points, but make sure model is highlighted. So you can click on remote points. So now we need 2 remote points for the supported structures for B and C, and then we need 2 for the forces. So we need a total of 4. So here, what I like to do is I like to click on them, press F2, change them to what they need to be. So we have a support at 2 meters, we have a support at 3 meters, F2, and then this one can be force at 1 meter, and then this one is going to be your distributed force. So now we're going to click on the edge finder, click that edge, select that geometry, and we're going to change the geometry of the x coordinate to be 2. As you see, it moves it. And this one we're going to do the same thing, except what we're going to do is have it at 3 meters. Our force, we're going to pick this top edge because that's where it's coming from. Apply, and the geometry, it's going to be at 1 meter. The distributed force is going to be the same thing, top again, and then it's going to be right in the middle of the distributed force, which is at 4 meters. So then we have our forces there. So here, remember, change the quality from aggressive mechanics to standard mechanics. You're going to insert 2 sizings, and then again pick the edges. Make sure you apply your geometry. Change the element size to number of divisions. So 16 for the long side, and then short side could be So now that we're done, as you can see, it never reached below 5%. Now, if it reaches below this threshold right here, what it will do is it will stop the program from running because it's already reached its maximum percentage that it's changed. So, but this is how you configure relative error, and this is how you redefine it per iteration. So, and the max here is about 32,000 nodes per elements, over elements. So, hope y'all have fun with this.